Alright, in 2.6 again we're going to apply the addition property of inequalities as well as the multiplication property of inequalities. So let's just look at the addition property first. Let's say we have an example of 5 plus 1 half x, and that's less than or equal to 3, and that's minus 1 half x. Okay? And so we have variables on both sides of the inequality, and so we can either move those to one side or we can move the numbers to the other side. So let's take a look at that. Excuse me for my cuckoo clock there. Anyways, let's go ahead, and I don't like negatives, so let's go ahead and move the negative 1 half x to the other side. So I'm going to add a half of x, and I'm going to have an half of x. And I'm going to move the 5 to this side, so I'm going to minus 5, minus 5. And so now I have 1 half and 1 half, which is a whole, x less than, and 3 minus 5 is negative 2. And so here I'm just using the addition property to move variables and numbers to the other side. I can also show that. So I will go to my standard setup, right? And so this is negative 1, negative 2. And since it's equal to, it's going to be a bracket, and it's going in this direction. And my interval notation would be parentheses, negative infinity, comma, to negative 2, and it's included, so it's a bracket. Right, so this is one way of doing that. That's the addition property. Let's take a look at the multiplication property of the inequality. Okay, so let's take a look. Let's do. Let's actually do. Yeah, let's do negative 7, and that is less than negative 1x. Okay, and let's make that all over too. Okay, so in this case I'm kind of forced. I have a negative symbol next to my x, so I'm going to have to deal with flipping the inequality. But first of all, this is dividing by a 2, so I'm going to actually multiply by 2 to both sides. Actually a negative 2, because a negative 2 times a negative 1 half is 1. And negative 2 times negative 7 is 14. And then I have to flip the inequality to go the other way to make it true. Okay, and so again, if I was asked to draw the graph, then I would have, maybe say, let's say 14 is right here. It would be a bracket, and it would go in this direction. So that I know my interval notation is going to be bracket 14 to positive infinity, parentheses. And so you have to get in the habit of drawing the graph, because you just can see exactly how the interval notation has to be written. Let's say we do another one. Let's say we have negative 8, and that's plus 4x, and that's less than or equal to 5x plus 3. And this time I'm going to play again with the negative, so I'm going to move the 5x over here so that I end up getting a negative. So I'm going to minus 5x minus 5x. And since this is a negative 8, I want to move it over here to the 3. I'll add 8. I'll add 8. Okay. And so then I get a negative x less than or equal to 11. Right? So 3 and 8 make 11. And then, of course, if I divide by the negative 1, I'm going to get x greater than or equal to negative 11. I have to flip it because I'm dividing by a negative. Now I have my graph. So this is 0. Negatives on this side, so probably right here is negative 11. And it's a bracket, so it's all the values greater than, so it has to be going in that direction. And so my interval notation is going to be bracket negative 11, comma, infinity, parentheses. And so this is looking at the multiplication and addition property of the inequalities.